We're going to take a look at two more examples of L'Hopital's rule, this time where we have to utilize L'Hopital's rule more than once to be able to get to the limit of a function. And so we have an example to where we have lim as x approaches 0 of 1 minus the cosine of 8x divided by x squared. So we have a rational function. So as always, we need to use direct substitution because we need to verify that it does indeed fit L'Hopital's rule. 1 minus cos of 8 times 0 divided by 0 squared. We know that this is going to be cos of 0. And cos of 0 is equal to 1, so this becomes 1 minus 1 divided by 0, or 0 over 0. And we have a indeterminate form, or an indeterminate form, which means we can use L'Hopital's rule. Now we're going to be careful because we have to use a chain rule, and we have to be cognizant of the fact that the 1 becomes 0 when we take its derivative. So we have lim as x approaches 0, derivative of 1 is 0, derivative of negative cosine is going to be positive sine. So we have 0 plus sine 8x, but then we have to multiply that by 8 because of the chain rule. Then we're going to divide by the derivative of x squared, which is 2x. Or another way to write this is the limit as x approaches 0 of 8 sine 8x divided by 2x. We're going to try direct substitution, and that's going to yield 8 sine of 8 times 0 divided by 2 times 0. And what does that work out to be? Well, this is sine of 0, and we know sine of 0 is 0. So we get 8 times 0 divided by 2 times 0, which is going to be 0 over 0, which once again is an indeterminate form. So as long as we keep getting indeterminate forms, we can go ahead and we can use L'Hopital's rule again. And we're going to use it on this limit right here, because that's the most simplified limit we have. Lim as x approaches 0. We know that the derivative of 8 sine is going to be 8 cos 8x. But once again, we have a chain rule. So we're going to multiply by the interior derivative of 8x, which is just 8. And then the derivative of 2x finally is 2. And we like that a lot because now we don't have a 0 in the denominator. Another way to express this limit is to multiply the 2 8s. So we're going to get 64 cos of 8x divided by 2. We're going to use direct substitution. 64 cos of 8 times 0 divided by 2. And we know that the cosine of 8 times 0 is cos of 0. Cos of 0 is 1. So we end up with 64 times 1 divided by 2, or our limit is 32. And I encourage you to utilize your calculator, trace the function until you get to 0, and then see if it does match up. Make sure that your calculator is in radian mode. All right, it's very frequent that our students like to work in degree mode because that's what you work with more frequently throughout your lives. But make sure your calculator is in radian mode when you're dealing with trigonometry. One final example. We want to use L'Hopital's rule to be able to evaluate e to the x minus sine x minus 1, x4, 5x cubed, 13x squared, the limit as it approaches 0. Let's start by substituting, as always. That's going to be e to the 0 minus sine of 0 minus 1 divided by 0 to the 4th plus 5 times 0 cubed plus 13 times 0 squared. In the numerator, e to the 0 is 1, sine of 0 is 0, so we get 1 minus 1 divided by 0 plus 0 plus 0, or 0 over 0. We get an indeterminate form. Let's now use L'Hopital's rule. Lim as x approaches 0, e to the x, derivative of sine is cosine, but it's still going to be negative. So we get e to the x cos x. We're going to divide that by 4x cubed plus 15x squared plus 26x. Direct substitution, e to the 0, cos 0 divided by 4 times 0 cubed plus 15 times 0 squared plus 26 times 0. E to the 0 is 1. Cos of 0 is 1. All right, remember, these are all zeros anyway. And so we end up with 1 minus 1 over 0 plus 0 plus 0 equals 0 over 0. So that means we would once again use L'Hopital's rule. And again, we're going to go back here and use L'Hopital's rule. And we're going to finally get an answer this time. So one last time, L'Hopital's rule, lim as x approaches 0, derivative of e to the x is e to the x, derivative of negative cosine is going to become positive sine. In the denominator, 12x squared, 30x, 26. Mercifully, we substitute 0 back in, and now we don't get 0 over 0. So by direct substitution, this becomes e to the 0 plus sine of 0 divided by 12 times 0 squared plus 30 times 0 plus 26. Sine of 0 is 0. E to the 0 is 1. This is 0 and this is 0. So it winds up being 1 over 26. So hopefully this illustrates the use of L'Hopital's rule more than once. As long as you keep getting those indeterminate forms, it's perfectly legal. The second that you don't get an indeterminate form, you have to go back and either show that it doesn't exist or use a different technique.